Okay, hello, welcome to the additional video. This is additional uh, video for exercise. So first look at this question, the surface area over the disk, blah blah blah, of the circular paraboloid, and you have all of the options. Okay, so pause the video and try first, okay, and we can compare our results. Okay, now to start with this, okay, first thing is we are going to describe this. Okay, describe the functions. Okay, so let the functions of two variables x, y as x squared plus y squared, right? And R, the area is the disk, right? The disk. Okay, the circle, which it x squared plus y squared equal to. You can write the surface area as S, okay, or S is equal double integral and square root of partial x squared plus partial y squared and then plus 1, and then let's say dx dy. Okay, so we can get the results. So for partial x we get 2x squared, okay, 4x squared plus 4y squared plus 1, okay, and then dx dy. And since dr is a circle, which is x squared plus y squared equal 2, we are going to convert this double integral into polar coordinates. So r is from full circle to pi, and then the radius is from 0 to square root of 2. So this inside will be, this will be 4 x squared plus y squared, and we can convert this to r. Okay. So we'll have 4r squared plus 1 half r dr d theta. Okay, so we can solve, and I think it's best to just take the substitutions method and make it u as for r squared plus 1. So you will have 8 r dr. So we have 1 over 8 in the front, and you will have a square root of u that you need to integrate. So this will be equal to 3 over 2, 2 over 3, 2 pi, and you have 1 over 8. Okay. Some sort of calculation. So 1 over 6, 1 over 6. And then you will have, based on your calculations, we will have 4, 9, 3 over 3 minus 1, so it's supposed to be 2. So 2 divided by 2 is 1, so 1 over 3, and this is supposed to be 9 square root 9, and then e minus 1, so it's supposed to be 2. It's supposed to be, what's the results? Is it 13 over 3 pi? Okay, but hopefully you can get the idea from here. Okay. Okay, another questions that we have. We'll have this volume of the solid lies above the cone. We have the cone and below the sphere. Okay, so perhaps it's going to be having the cone like this, okay, and then having a sphere like that. So you're going to have this side here, right? That's your volume if you have this 3 dimension like that. Okay, but I think doesn't really matter the drawings, but as long as we can see the conversions for xyz to the spherical coordinates, right? Okay, but you can try by yourself. Okay, try to convert to spherical coordinates, whether you can try convert first and then use the triple integral to solve. Okay, let's write down this conversion. So x is rho sine phi cos theta, y is rho sine phi sine theta, and z is rho cosine phi. Okay, and then we can write the z, the cone, and also the sphere. Now we have rho cosine phi for z equal, exchange all becomes square root of 3 rho sine phi. Okay, and then rho squared sine squared phi plus rho squared cos squared phi, okay, is equal to rho cosine phi. This is from the sphere here, okay, right? Because the cos squared theta plus sine squared theta is equal 1, so we can remove that. So we are having rho is cosine phi, okay, so we can have rho we will get from 0 rho until cosine phi, and then we will get this tangent phi is equal square root of 3, which is pi over 6. Not square root of 3, it's 1 over 3. Okay, sorry, it's 1 over 3 square root of 3, right? This will be resulting the theta is pi over 6. Okay, so we can try to use the volume, and we can let the theta to be outside, okay, because there's, I think, no theta inside, and then 0 pi over 6 and 0 cosine phi, and rho squared sine phi d rho d phi d theta. Okay, and then we can solve one by one, and I think we can just solve the outside the theta because there is no theta inside, and we can solve the rho. And plug in the cos, so this will be 2 over 3 pi, or maybe let me just, oh yeah, maybe just take integral, and then cos cube minus 0, so this is sine phi. Take substitutions, so we will have a negative, okay, negative 2 over 3 pi and then this will be cos with power 4, right? So u3 du, this will be u4 divided by 4. So cos cube phi divided by 4 from 0 to pi over 6. Pi over 6 is, oh sorry, it's plus 4. So square root of 3 over 2 squared is 3 over 4, and the squared is 9 over 16. So 9 over 16, 9 over 64. This is the multiplied with the 1 over 3. This is supposed to be 32, 96. So it's supposed to be 9 over 96. Is there any answer? It's 7. Let me check. Oh, it's supposed to be so it's let me write correctly. So this is 9 over 16 minus 1, right? Yeah. So 7 over 16, and this is 6. So it's supposed to be 796 pi. Okay. So this is the answer. Okay. Okay. I hope you get the same results with me. All right. The last question for today's additional video is this value. Okay. So we need to find the value of double integral. We have x minus y over x plus y dA, and we have this vertices. Okay, this vertices as in our square. Okay. Okay, so you can pause the video and you can look out the results. Okay, since this is the square, and I believe that we can observe through the fraction here, we can set our transformations for u is x minus y and v is x plus y. Or if you want to make this x plus y, this is x minus y, that's okay, as long as you make the calculation is in a consistent way. And we can make out the, let's plus this to make 2x u plus v. X is half u plus v. Okay, and then minus that to make 2y u minus v, and y is half u minus v. Okay, and take the Jacobian. Take the Jacobian. It's half, okay, and then half, negative half. This is supposed to be negative half or still half. Okay. So the double integral, this is going to be, now the results from the uv is we can take u is x plus y, so 2 and negative 2, right? And then x plus y 2, 0, okay, 4, 0, and 4 and negative 2. Okay, so from here we get the u is between 2 and 4, and v is between negative 2 and 0. and we can take that into our calculation. So we have phi over u Jacobian here, half du d phi, okay, if you want, because I think this is the same. This it's a square. It's not a trapezoid, right? So we don't need to be worried about the line equation. So we just plug in all the constant here, and if you want to switch the order, not really a problem. So half. So this will be phi ln u, right? From 2 to 4 d phi. This will be 4 minus 2, or ln 2, right? ln 2. So ln 2 over 2. This will be having phi squared over 2 from negative 2 to 0. So 0 minus minus. Okay. So it's supposed to be having 4. 4 divided by 2 is negative 2. So it's supposed to be having negative ln 2, right? So it's negative 2 multiply with the with half, it's negative, right? So it's negative ln 2. This is the answer. Okay, and I think that's all for the additional video. So hopefully you can take some time to working on more exercise in the future. Okay, and see you later.